Okay, the next trend we're going to look at is ionization energy. Ionization energy is the energy required to remove an electron from a ground state gaseous atom. So it's removing a single electron. It's usually expressed in kilojoules per mole, and you can have multiple ionization energies. So if I start with metal M and remove one electron, that's called the first ionization energy because I made a +1 ion. The second ionization energy comes from taking that +1 ion and making it a +2 ion. Third ionization energy comes from starting with the +2 ion and making it a +3 ion. So you know it's stepwise. Each ionization energy, you start with the ion from the previous step and just remove one more electron. So as you continue to remove electrons, they get harder and harder to remove because remember, a positive ion starts getting smaller. As the radius goes down, the remaining electrons are pulled closer to the positive nucleus, so it makes it harder to remove the electrons. So when I look at trends in ionization energy, and we'll just look at first ionization energy, ionization energy decreases as we go down the group. So as you go down the group on the periodic table, ionization energy decreases. And that is because as n goes up, the radius goes up, so the valence electrons are farther from the nucleus and they're easier to pull off. Likewise, ionization energy increases from left to right. There are exceptions and we will talk about those later. Okay, so just know the general rule right now. The general rule is left to right, ionization energy increases, and that's because the greater effective nuclear charge holds the electrons more tightly. In other words, smaller radius, the electrons are closer to the nucleus, the more tightly they're held, the more energy it takes to pull them off. So here's a graph of first ionization energies, and you can see the general trend from left to right is to decrease, and then, or from left to right, this is one group, from lithium to helium. The general trend is to go up, but there are some exceptions. Sodium to argon, the general trend is increasing, but there are some exceptions. And again, when we get into the transition metals, there are lots of exceptions. And then you'll notice it's easiest to see either the group 1s. You notice the ionization energy is going down as we go down the group, or my group 18s, ionization energy decreases as we go down the group. Okay, so let's arrange each of these elements in the expected order of increasing first ionization energy, easiest to remove to hardest to remove. So if we look at our magnesium, sulfur, and silicon, again, they're in the same period. So magnesium with the largest radius is going to have the smallest first ionization energy. Sulfur with the smallest radius is going to have the largest ionization energy. Silicon's in the middle, so its ionization energy is in the middle. If we look at our arsenic, nitrogen, and potassium grouping, in the same group. So from smallest to largest, first ionization energy, it's the opposite of the radius trend. So the smallest ionization energy is the furthest down the group, which is arsenic. The highest ionization energy is for nitrogen because it's at the top of the group, and phosphorus is in the middle. And then we have arsenic and germanium in the same period, and arsenic and phosphorus in the same group. So again, we need to look at them period by period or group. So this time we'll look at the first two are in the same period. So arsenic is further to the right, so its ionization energy is higher than germanium. So germanium is going to come first, arsenic is going to come second. When I look at arsenic and phosphorus, since arsenic is further down the group, it has a lower ionization energy. Phosphorus has the highest ionization energy. So that's some basics on trends in ionization energy.